Welcome to the first lecture in calculus series. In this lecture, we will be discussing what is limit and how to calculate limits of certain functions. So let us try to understand what is limit with an example. Suppose doctor told you to measure the blood pressure of a person every day at 10 a.m. but you do multiple measurements. So let us suppose you started doing measurements from 950. So 950 to 959, you got the reading as 120 by 80, that is a normal range. And at 10 a.m. you observed that the reading as 150 by 80, and from 10:1 to 10:10 you observed that again you got a normal reading 120 by 80. And if you show these readings to the doctor, doctor might say it as a normal range 120 by 80. The reason is at 10 a.m. he might say it as whatever the reading that you got, it might be a wrong reading or a faulty behavior of a machine. So what does doctor is considering? Doctor is considering the value of BP when it is approaching 10. So that is what we call it as a limit. Uh, so in some cases what happens is, if the behavior is defined as some f of x at some x equal to a, that f of x might not be defined or might be having some faulty behavior, then we are going to calculate what is the value of f of x when x approaches to a, that is just before 10 a.m. what is the reading, just after 10 a.m. what is the reading, and we will use that to find the value at 10 a.m. So in this case we say that the value at 10 a.m. as 120 by 80 only. So that's how the limit is defined. So now, limit is defined as the behavior of a function when an input value gets closer to the specific number. So it is defined as limit extends to a f of x. So this is the notation that we are going to use, and you will get some value. So when x closer to the a, what is the value that f of x gets closer? That is what we are defining it as a limit. So now we need to, so when you will say that the limit exists, so you have to define something called a right hand limit. So that is limit extends to a plus f of x. In the case of that BP reading, so from 10:1, 10:2, 10:3, so whatever the readings that we are getting, that we define it as a right hand limit. So when x is some a plus epsilon, what is the value of f of x? Similarly, the left hand limit, that is limit extends to a minus f of x. When x is some a minus epsilon, what is f of x? Like 951, 952, so on up to 959. So when you will say that a function limit exists when limit extends to a minus f of x is equal to limit extends to a plus f of x. When both right hand limit as well as the left hand limit are same, then we can say that limit exists, and we can say that the f of x value as that limit value when x approaches to that a. So let us try to understand with examples. So there are different ways of evaluating the limits. Suppose f of x is a polynomial or some rational function, and you also have some f of a is defined, then we will consider limit extends to a f of x as f of a. Okay. So in some cases what happens is, you might get some indeterminate forms like 0 by 0. Then we are going to apply factorization or a rationalization. So factorization is whatever the numerator and the denominator that we have, we do factors and then we cancel some common factors in the numerator and denominator. And similarly, we apply rationalization, multiply either a numerator and a denominator by the conjugate of the square root. So to eliminate those square roots, so just to convert into a form of a square minus b square. So now with the direct substitution here, x square plus 2x plus 1, we need to find out a limit at when x tends to 3. So, and here f of 3 is defined because 3 square plus 2 into 3 minus 1 is defined. When it is defined and it's not in indeterminate form like 0 by 0 or infinity by infinity, then we can directly calculate. So we can say substitute directly 3 here. 3 square plus 2 into 3 minus 1, you are going to get 14. Similarly, x plus 5 by x minus 2, when it is not in indeterminate form, you can directly substitute, that is minus 1 plus 5 by minus 1 minus 2, so you are going to get minus 4 by 3. Okay, so the next one is when it is in indeterminate form like 0 by 0. Here limit extends to 2 x square minus 4 by x minus 2. If you substitute 2, you are going to get 0 by 0. When it is in indeterminate form, one of the ways of solving is just do a factorization. So we will get here this x square minus 2 square you can write. So this a square minus b square, you can write it as a minus b into a plus b. So x minus 2 into x plus 2. So x minus 2 will cancel out. So you'll get 4. Similarly, when there is another example, limit x tends to minus 1, x square plus 3x plus 2 by x plus 1. As x minus x plus 1 is a factor of x square plus 3x plus 2, so you are going to get 0 by 0. Then, so one of the ways of solving is just do a factorization. So you will get x plus 1 into x plus 2 by x plus 1, x plus 1, x plus 1 will cancel out. So you will get x plus 2, that is 1. So just substitute now x minus 1, so you will get 1. And similarly rationalization. So when you have square roots of this form, limit x tends to 0, square root of x plus 1 minus 1 by x. So if you substitute 0, then square root of 1 is 1. So 1 minus 1, 0, 0 by 0. Whenever you get this indeterminate form 0 by 0, so for square root of x plus 1 minus 1, the conjugate form is square root of x plus 1 plus 1. So multiply both denominator and numerator by square root of x plus 1 by x, square root of x plus 1 plus 1. So if you do that, it will be of the form a square minus b square. So x plus 1 minus 1. So you will get x by x into square root of x plus 1 plus 1. So now it is not in indeterminate form. You can substitute x as 0. So if you substitute x as 0, you are going to get 1 by 2. Similarly, when you have another example, limit x tends to 4, x minus 4 by square root of x minus 2. For square root of x minus 2, square root of x minus 2, the conjugate form is square root x plus 2. So if you do, then you are going to get an answer as 4. So now, so there is another form. Whenever limits are in the indeterminate form like infinity by infinity, then so you can use a powerful tool called L'Hospital rule. So what we do is, when you have limit extends to a f of x by g of x, and both f of x and g of x are giving either by 0 by 0 or infinity by infinity, then this limit extends to a f of x by g of x is same as limit extends to a the derivative of x by derivative of g. So f dash x by g dash x. Okay, so let us try to understand with an example. Now you have a function limit extends to 0, f of x by sin x by x. Now sin 0 is 0 and x by x is also 0. It is in the form 0 by 0. So what you do is you take the derivative, that is sin x derivative is cos x, and x derivative is 1, so you are going to get cos x. So cos 0 is 1, so the answer is 1. So limit x tends to 0 sin x by x. This is one of the famous examples, so it gives 1. Similarly, limit x tends to infinity e power x by x square. Now it's in the e power infinity by infinity, so infinity by infinity form. Now you can apply a derivative, so you will get e power x derivative is e power x, and x square derivative is 2x. Still it is in indeterminate form. Again you can apply L'Hospital. So again, if you apply L'Hospital, you will get e power x by 2. So when x tends to infinity, e power x is infinity, so the answer is infinity. Thank you.